So now we were just saying that it's growing. So two of these choices don't represent growths at all. So I could eliminate the two choices that have bases that are lower than 1. Get rid of 1 and 4 immediately. Choices 2 and 3 both have bases greater than 1, so they're increasing. But if it's increasing at a rate of 14%, so let's look at that equation that was up top for growth. A times 1 plus r to the x power. Here, the A, what you're starting with, is the 7 million households. That's how many households had computers in the beginning. Then your rate at which it's increasing is 14%. So I would change that to a decimal, move the decimal 2 places to the left, and it's 0.14. So when you plug that in, you get y equals, instead of a, I'm going to put 7, 1 plus the 0.14 to the x power. And that's going to be choice 3. Instead of saying 1 plus 0.14, they just make the base 1.14. Number 3. If you have $750 to invest in a savings account that earns 5% interest compounded annually, write a function that will determine how much money you will have after t years. Then we're going to use the equation. So if we're talking about investing money in a savings account with interest, are we going to use the growth equation or the decay equation? Growth. So again, I'm going to use the same equation as in the last question. If it's talking about decay, the only difference is going to be it's 1 minus r instead of 1 plus r. You're starting with how much money? $750. What's the rate? 5%. However, you have to change that to a decimal. Changing 5% to a decimal, and you move the decimal 2 places to the left, you have to remember to put it as 0.05, not just 0.5. So when I plug it in, I get y equals 750 times 1 plus 0.05 to the x power, or you could just write it as 1.05 to the x power. So that's the first part. It asks to write a function. There's our function. Now use it to find out how much money would be in the account after 20 years. So 20 years is going to be plugged in for the power, for the exponent. So $750 times 1.05 to the 20th power. And when it's money, we will automatically round to the nearest cent and get 0.97. Final answer. Okay? Moving on. Oh, now it's not letting me. Okay, and thank you. Next one. In the 2000-2001 school year, the average cost for 1 year at a 4-year private college was $16,332. That was a long, long time ago, which was an increase of 5.2% from the previous year. If this trend were to continue, the equation would be, so they give you the equation here, could be used to find the cost, C of X, of a college education X years from 2000. Find C of 4. So do you guys know what that means, C of 4? If we're plugging in 4 for X, that means we're finding how much college would be expected to cost 4 years after that 2000-2001 school year. So we could look back at records to see how accurate this was. And I'm going to plug in, and hopefully not freeze my screen again. 16,332 times 1.052. Go outside the parentheses before doing the exponent. And I get 220, hold on, how many zeros is there? 3. 3 zeros, 3, and then 0.33. So $20,003.33. If this trend continues, how much would parents expect to pay for their newborn baby's first year of college? Assume that you go to college in 18 years. So that you would have to find C of 18. 16,332. Again, this is all in the past, so you'd be able to actually look this up now. But they want it using this equation. Actually, instead of retyping it, I'm just going to go back and put in as the exponent 18. And now my answer is 40674.54. $40,674.54. Now, this is the first problem that we're talking about, depreciation or decay. As cars get older, they are worth less than they were when they are new. This is called depreciation. Assume you bought a new 2007 car for $13,700 and that it depreciates at approximately 20% a year. An equation that will model the value of your car via T, where T is the number of years since 2007, is, they give you the equation here. Let's look at the parts of the equation. Via T equals the 13,700, that's your starting value of the car. How did it get the 0.8 as the base? Well, if you're depreciating at a rate of 20%, your base is going to be 1 minus the rate with depreciation. So 1 minus 20% is 0.2, which gives you the 0.8. So they did that for you. So you didn't have to do this at all. I just wanted to show it to you. So now they want you to find V of 1 and explain what that means in terms of the value of your car. So to find V of 1, I'm just going to plug 1 in for the T. 0.8 to the first power. So that's 13,700 times 0.8. Outside the parentheses, you could put a caret of 1 or nothing. Exponent of 1. You get 10,960. So now it wants to know what this means in terms of the value of the car. Well, 1, if you're plugging it in for the T, is years. So 1 year after you buy the car, it is worth $10,960. So if you understand that, you understand what's going on. The car started at a value of $13,700. 1 year later, it depreciated to $10,960. Okay, it depreciated at a rate of 20%. So that's why we have a base of 80%. If it depreciates 20%, it's worth 80% the following year. So this is your final answer. Okay, I'm going to do 2 more with you, and then you're going to complete the last 3 on your own. During an economic recession, a charitable organization found that its donations dropped by 1.1% per year. So again, what's happening? It's going down. Before the recession, its donations were $390,000. Write an equation to represent the charity's donations since the beginning of the recession. So again, we're going to use the decay equation. So the base is going to be 1 minus R instead of 1 plus R. My A and my R are given to us in the problem. What's the starting amount? Well, at the beginning, the donations were $390,000. So that's going in for the A. The R is 1.1%. but we always change it to a decimal, so I hope you do that too. So I'm going to have 0.011 as my r. So the function is y equals 3 nines followed by 4 zeros times, I could either put in 1 minus the 0.011, or I could just put it in the calculator. What is 1 minus 0.011? And I'll get my 0.989 to the x power. Okay, if you don't want to do the subtraction, again, you could just keep it 1 minus 0.011. So that's the equation. That's the answer for part A. What is the amount of the donations 5 years after the start? And this says round to the nearest dollar instead of cent. So 5 years is going to be the exponent. So I'm going to copy the equation down, and I'm going to put in 5 for the exponent. So 390,000 times 0.989 outside to the 5th power, and 369016.73, but it said nearest dollar, so the 7's going to make the 6 go up. So 369017, if I put the comma, it's $369,017. Final answer. One more I'll complete with you. In 2000, 2,200 students attended Polaris High School. The enrollment has been declining 2%. So that means we're using the decay formula annually. Write an equation for the enrollment. So I'm going to use y equals a times 1 minus r to the x power instead of 1 plus r. The a is what you started with, the 2,200 students. The r, the rate at which it's declining, is 2%. So you have to be careful again when you change it to a percent. You're moving 2 places to the left, giving you 0.02. So you get y equals 2,200, parentheses, 1 minus 0.02, or 1 minus 2%. You're going to get 98%, or 0.98, to the x power. There's your equation. If this trend continues, how many students will be enrolled in 2015? Well, this started in 2000, so how many years goes past before 2015? 2015 minus 2000, 15 years. Did you have to do the subtraction? Not at all. So I'm going to plug in the 15 as my exponent. 2,200, parentheses, 0.98 to the 15 power, and I get the 1,624 numbers to the nearest whole number because we're talking about people. So 1,620, the 4 is going to go up because of the 8 in the tens place. So it's 1,625. So make sure you convert the rate to a decimal before plugging it in. Use the correct formula, the one with the 1 plus r if it's growth, 1 minus r if it's decay, and plug in correctly and round.